So we've now seen lots of evidence that some languages neutralize voicing contrasts in different contexts, and most of that evidence has come in the form of surface distributions. Here's a bunch of words in Muniche or Maori or English, and here's what kinds of obstruents you do and don't find in different positions. We also looked at some evidence from loanword adaptation. I was trying to convince you that this is evidence for the productive nature of phonological knowledge, right? That this is not just about generalizing over things that happen to be memorized in your lexicon, that it's a system of productive knowledge that can be applied to new objects. That was what the Maori loanword example was about. And there's another kind of evidence that we very briefly touched on at the end of last week, and that was evidence from alternations. And these are cases where the same morpheme is pronounced with different properties in different contexts. So earlier when we just now looked at the typology of voicing and voicing neutralization across languages, we saw that there's a high rank constraint in German that marks voiced obstruents at the ends of words. This was the context-specific markedness constraint. Don't have a voiced obstruent at the end of a word. And in German, this dominates the faithfulness constraint that preserves voicing values from underlying representations. And so it predicts that there can't be any voiced obstruents at the ends of words, and therefore no voicing contrast at the ends of a word. And so here's a question. What would happen if a lexical entry underlyingly did have a voice stop word finally? The answer that this constraint ranking gives, where this is above faithfulness, I'm just going to write F for the faithfulness constraint here, it's ident voice. What this predicts is that if you did have a lexical entry that happened to have a voiced obstruent at the end of it, and you pronounced that lexical entry, well, we wouldn't really know, because that final consonant would be pronounced voiceless anyway. So there'd be no way to even tell if there was a voiced obstruent morpheme finally in German. In fact, if you're a German learning infant, how would you ever be able to tell the difference between a lexical entry that has a final voiced obstruent and one that has a final voiceless obstruent? If they're all showing up the same way on the surface, it would presumably be impossible to learn that there's an underlying distinction in feature values, because there'd be no surface evidence for it whatsoever in the language, unless that morpheme could be put in a context where that underlying voice stop was no longer word final. And that's exactly what we saw at the end of last week, that if you take certain morphemes in German and pronounce them so that they're not in isolation, but instead have a vowel following them, you can actually see voicing contrasts emerge in that morphologically complex context that aren't visible or inferable in the simple morpheme isolation context. So more generally here, this relates back to the overarching form of a generative grammar that we started talking about at the beginning of the semester. Right? So in our theory, we have our lexicon, where you learn the words of your language, the morphemes of your language. Those morphemes, their sound patterns are arbitrary in the sense that there's no predictable meaning associated with particular phonemes in a language. You just learn through experience what the particular morphemes are, or sound strings are, that are associated with particular meanings in your language, and you memorize those, right? There's nothing about the concept dog that means that in English it has to begin with a voiced stop that's coronal. That's a sort of accident of how we happen to pronounce that morpheme. It's something that we just learn as infants and memorize. Now, once we've memorized, so that's sort of one locus of knowledge in this theory, implicit knowledge, is the stuff we know about which morphemes mean what in our language. And there's a separate system of knowledge that is our generative grammar, our function, that filters down all the conceivable phonological forms we could be presented with to the pronounced forms that are actually legal in our language. Right? So by hypothesis, anything that's phonologically predictable that speakers can impose on new items or new stimuli is something that has to be in the productive part of your grammar. That is, basically your constraint ranking better get you all the phonologically predictable facts in your language because you're able to project those phonological patterns onto novel objects. Versus the lexicon, the only thing you need in the lexicon is the stuff that's phonologically unpredictable, that you can't learn as a sound pattern, that's arbitrary and is just part of your culture that you have to pick up from experience. So if we're finding that some morphemes are pronounced in different ways in different contexts and that that's phonologically predictable, it's important in a generative grammar that the phonologically predictable part can't be in the lexicon. The underlying representation has to be the same for a morpheme in every phonological context. Exactly the same, exactly the same. If you change this through affixation, then the way you get phonologically predictable differences in this theory is that the exact same underlying representation goes through the grammar. I'm going to put just a big black box here. This is our function that filters out impossible forms. And this complex form also goes through the grammar. Now you can get different forms out of this function. Right? So maybe here we're going to have an output form with one set of properties. I'll call this morph1. And here maybe we're going to get a form with a different set of properties. I'll call it morph2. But if this difference between output morph1 and output morph2 is phonologically predictable, it has to come from the grammar, from context-specific constraints in particular, like this one. It can't come from the lexicon. You don't store two separate forms of this morpheme. You have one stored underlying representation from which phonologically predictable changes on the surface can be derived by the grammar. So this is a pretty important architectural point. And let's go back to the German data here that we saw earlier, where we had a bunch of singular forms on the left, and they all end in voiceless stops, and a bunch of plural forms on the right. And what we see is that the surface variance of the particular noun morphemes that we're looking at sometimes change when you put the plural on, and they sometimes don't. So what do we conclude from that? Well, here's what we're seeing here. Some of these forms, first of all, we need to do the morphological segmentation. One of these columns involves a morphologically simple form, and one of them involves a morphologically complex form that is more than one morpheme. Which one is which? The plural has two morphemes, while the singular only has one. What is the nature of the plural morpheme here? That is, what is its underlying representation and where does it occur? Well, it looks like it's a suffix, that is, it occurs after the stem to which it attaches. The stem, by the way, is whatever an affix attaches to, so that can be morphologically simple morphemes, as in this example, where these are all just noun roots. Or it can be a more complex derived word. You can do some things to a word first in order to build it from different morphemes and then attach an affix to it. The word stem just means anything that an affix can attach to. So it looks like the plural, this particular plural in German, there are others, but this is the one we're looking at, is a suffix. It attaches at the end of a stem, and it looks like the underlying representation, or the surface form at least, is always a schwa. If we don't see different surface forms, if it's always the same surface form, then we're going to assume that that's also the underlying representation. So what we have here is a bunch of words like Wort, and then those same words with a schwa, the plural suffix, following them. So this is going to be the input in the left column for word. This is going to be the input in the right column for words. And if there's a difference in how this morpheme surfaces in the two contexts, then we want to derive that in the grammar. In this particular case, there is not. So when we look at the surface forms, we get the form Wort here and the form Worte here, where the morpheme break, again, is after the stem. So this particular morpheme, the noun word in German, does not alternate. It always has this form Wort and Wort. You could say that this has one allomorph, although it would be a little bit funny to use the word allomorph if there's only one of them. That's not incorrect. It has one surface form. It never changes. We assume, therefore, that this must be the underlying form. Right? There's no reason to posit any other underlying form if this is the only way it ever surfaces. So far, so good. Change this to murder. Mord. And here's what we can say about this. In the singular, this looks almost exactly like Wort, except it happens to start with a different consonant, and that's an arbitrary fact about lexical entries, so we'll just put that in here. But here, that final coronal stop shows up as voiceless in this context, voiced in this context, but voiceless in this one. In other words, there are two surface forms of this morpheme. In German, we have the Mord form and the Mord form, and these are two allomorphs of the same morpheme. So here's an allomorph with a final voiced stop, and here's an allomorph with a final voiceless stop. Given what we've just said about a generative grammar, if this difference is phonologically predictable, we better derive it from the grammar and not from assuming that the, say, underlying form in this case is different from the underlying form in this case. That would mean that this alternation is basically an accident and is arbitrary. But we don't think that when we look at this entire data set. What we can see is that in between two sonorants or two vowels, as in the right column, sometimes the morpheme final stops are voiceless, as in Wort, and sometimes they're voiced, as in Morde. But in the simple column, where they're word final, they're always voiceless. What that means is that the distribution of these morphs, allomorphs in this case, is phonologically predictable. So a final stop in a morpheme is always voiceless if it's at the end of a word, but there's contrast elsewhere. So we better be deriving these two allomorphs from the same underlying representation. One of these contexts is giving us more information, more unpredictable information, more information about what's in underlying representations in the lexicon than the other context. Namely, a context where there's contrast will always tell us more about the lexicon, about underlying representations, than a context where there's no contrast. So we better be getting our information about underlying representations from the right column, from the plural forms, because here we have unpredictable phonological information, namely some stops are voiced and some are voiceless. That information better be in the lexical entries. Once we've decided that this voicing phenomenon has to be in the underlying representation, it better be here as well. So now there's really no sort of question or secret about what happens here. This just surfaces faithfully. These are the underlying forms of these two morphemes, and they show up here. Here we're going to need to say something, but we've set this up precisely so that it's easy to say what's going to happen here. Namely, German has a high-ranked context-specific markedness constraint that says don't have voiced obstruents at the end of a word. Here, this underlyingly voiced obstruent ends up at the end of a word, and in order to satisfy this goal in the grammar, which is in between the lexicon and the pronunciation of this word, in order to satisfy the highest priority in the grammar, this sound must devoice. Over here, where you get these two words, two morphemes concatenated in the input, this sound is no longer at the end of a word. This constraint entirely fails to apply in the grammar. And this surfaces faithfully. There's no reason to violate the faithfulness constraint ident voice because there is no high rank constraint that devoicing this would favor. So in other words, the input to our tableau in optimality theory may just be a single morpheme, as in this case, and if that's what happens, then we'll get final devoicing in German. Or the input might be a sequence of morphemes, as in this morphologically complex word in this tableau, because the word final sound is a vowel and not an obstruent. There's absolutely no influence from this context-specific markedness constraint, and instead we get faithful surfacing of voicing contrasts before a vowel, but not at the end of a word. This type of phenomenon where you get more than one surface form of a single underlying representation or a single morpheme or a single lexical entry, we refer to this as an alternation. So alternation is when the form of a morpheme varies depending on context. So for instance, in German, we find with the word, is this thief, deep? Yeah. So if you look at the word for thief, sometimes it surfaces as deep, and sometimes it surfaces as dieb, namely in the plural form. So we would say that deep alternates with dieb, and notably that final plural schwa, this is not part of the allomorph. Right? The allomorph is just the form of a single morpheme that appears in a certain context. Right? It's not the entire word form. So the two more allomorphs of this morpheme mord are mord and mort, not modda. This is not part of the allomorph, just this is. Same thing with deep and dieba. The two allomorphs here are deep and deeb. I put this suffix on, which should be a schwa, but it's written as an a vowel here. I put that suffix on to show the context where the other allomorph occurs, but the allomorphs themselves are just the forms of the stems here. So this is a case of stem allomorphy, where we looked at a whole bunch of different stems, all the nouns in this table, and we saw that a bunch of those stems alternate, a bunch of them don't alternate. And that's a case of stem allomorphy. The other major thing that we'll look at in this class is cases of affixel allomorphy. And this is illustrated here with an English example, and this was covered in several of the textbook readings, notably in the Hayes reading, where this is exactly the same set of facts for the plural, for the third person present tense verb endings, he eats, he plays, as well as the past tense verb endings, as in, he hissed versus he pleased. You get exactly the same set of facts here. So in English, this particular plural, these forms are boats and bones. And here, it's not the roots that are alternating. Boat is boat and bone is bone. What's alternating here is the plural suffix, which in the first form is a voiceless s sound, but in the second form is a voiced z sound. Right? So this is another case of allomorphy. This is not stem allomorphy. This is affixel allomorphy. And so this is the other major kind of thing we'll look at here. Normally in problems where we're trying to figure out allomorphic variation, for the affixel cases, we'll usually be looking at a single affix, and we'll be trying to figure out how the alternations that affix undergoes are phonologically predictable. In cases of stem allomorphy, like the German one we've just looked at, we'll often be looking at lots and lots of alternating morphemes and asking how they differ from non-alternating morphemes. So there's slightly different kinds of problems, but they both involve this basic notion of a single underlying representation for a morpheme being cycled through different phonological contexts, which have different grammatical principles applied to them, and therefore yield different surface variants or allomorphs. Well, I've sort of saved this for last because it's the most complicated part of this semester. This is really the strongest evidence in most languages that grammar is robust. That is, that it can fix illegal structures if they arise in the input. This is not just an exotic ability that you have when you're adapting foreign words to be pronounced in your language, or maybe judging some weird nonce words you've never heard before, or something like that. This is an ability that has reflexes and pieces of evidence everywhere in your language. Every time you speak, you are doing phonological alternations, right? So you are applying your system of phonological knowledge all the time to various morphemes in your language, and alternations are some of the strongest pieces of evidence for your productive system of phonological knowledge. So we saw some cases of fixing or repairing illegal structures in loanwords, and this is exactly the same thing, except it's a much more common situation. Here, the illegal structures are created through morpheme concatenation, or in this case, through not concatenating morphemes. If you don't put anything after this underlying representation, there's an illegal structure here. That illegal structure is the one that violates this markedness constraint. Right? In other cases, we'll see you put two things together and it creates an illegal structure that wasn't there before, and you can also get alternations from that. This is going to pose a new analytical challenge to us, and most of the rest of the class is going to be taken up with learning to reason through problems that involve underlying representations and alternations. This is a large part of what phonology is really about. Here's the new challenge. Rather than just looking at a bunch of words and coming up with some surface generalization about what words are like in language X or language Y, now we need to look at the surface forms. This is the data that we get. Whether we're a linguist or an infant learning German, we only get these pronounced forms. From these pronounced forms and the patterns in them, we now need to discover the underlying representations of the morphemes in question and how the grammar must be in order to combine with different morphemes to produce the attested set of surface variants, the allomorphs of that morpheme. This is a different kind of challenge than we've looked at in this class so far, and it's going to be pretty tricky and subtle stuff, but this is what we're going to be focused on.